The position of the particle which moves along a straight line is defined by x is equals to 2t cube minus t square minus 2t plus 4, where x is in meters and t is in seconds. Determine the following. First question, the time at which the velocity will be 0. And second question, the position and distance travelled by the particle at that time. And acceleration of the particle at that time. And last question, the distance travelled by the particle from t is equal to 3 seconds to t is equal to 5 seconds. So in this question, position of a particle which moves along a straight line. So it means there is a particle which moves along a straight line, and here position of a particle as a function of time is given. See. So position of a particle, so here position denoted by small x, here small x represents position of the particle, position of the particle. So x is equals to 2t cube minus t square minus 2t plus 4. Here position measured in, meters and time measured in seconds. So here position measured in meters and time measured in seconds. Okay. So we have to find first question, the time at which velocity of the particle is 0. So we have to find the time, means t. So at which velocity of particle is 0. So at what time the velocity of particle is 0. So a time దగ్గర velocity of particle 0 అవుతుంది, అది మనం find out చేయాలి. Okay, this is my first question. So to find time at which the velocity of the particle is 0, first of all we know that velocity, instantaneous velocity, not velocity, instantaneous velocity. So instantaneous velocity is given by derivative of position of a particle with respect to time. Derivative of position of a particle. So x means position of a particle. So to get instantaneous velocity, so we have to find derivative of position of a particle with respect to time. So formula for velocity is dx by dt. And what about acceleration? Acceleration denoted by small e. Acceleration is equal to derivative of velocity with respect to time, dv by dt. So acceleration means rate of change of velocity with respect to time. Okay, we have to find derivative of velocity with respect to time. So v is equal to dx by dt, a is equal to dv by dt. So instantaneous velocity is equal to rate of change of position with respect to time, or rate of change of displacement with respect to time, and instantaneous acceleration is equal to rate of change of velocity with respect to time. So we have to use these two concepts here. See, first of all, here we need velocity as a function of time. We need expression for velocity. So velocity ko expression కావాలి మనకి. So we have already position. So what is the formula? V is equal to dx by dt. So V is equal to, so d by dt of, so what is x? Here x is equals to 2t cube minus t square minus 2t plus 4. Okay. So now apply derivatives concept. In derivatives, very important, d by dt of t power n. What is the formula? Like d by dx of x power n into t power n minus 1. And next one, d by dt of constant. Here c is constant, any real number. D by dt of constant is what? 0. Okay. Next, one more formula. D by dt of k into some f of t. It means derivative of this function with respect to t. So this function contains a constant and variable. Let us consider some c. So product of we are finding derivative of product of constant and variable function. This is constant and this is variable function, some variable function. So we can write it as, take out constant from out of the derivative. So then we get c into d by dt of variable function f of t. So here I am going to use these three formulas. Okay. So whenever we are finding derivative of product of constant and variable, we simply separate constant, or we simply take out constant out of the derivative and we do derivative of variable function. So apply these formulas here. Now v is equal to, here 2 is constant, take out 2 out of the derivative and derivative of t cube, use this formula. Here n is equal to what? 3. So 3 into t power 3 minus 1, 2, 3t square, minus derivative of t square, 2t, minus 2 constant, derivative of t, 1. Okay, now use this formula, you will get 1. And derivative of constant is equal to what? 0. 0. Therefore, velocity v is equal to 6t square minus 2t minus 2. Okay. This is velocity, expression for velocity as a function of time. So here we have expression for velocity v is equal to 6t square minus 2t minus 2. Okay. Using this equation, we can find time at which velocity of the particle is 0. So finally we derived relationship between velocity and time period. So we have an expression for velocity in terms of time. So in question 1, we have to find time at which the velocity of the particle is 0. So it means for what values of or for what value of t this velocity is equal to 0. Okay na? So ikkada t place lo ఏ వాల్యూ తీసుకుంటే మనకి velocity 0 అవుతుంది. Okay na? That is our answer. So we have to find value of t. Okay na? So to find value of t, we have to make velocity as 0. So v is equal to 0. Okay. So velocity is 0. Velocity of particle is 0 only when this expression is equal to 0. This expression must be equal to 0. So put v is equal to 0 here. Then 6t square minus 2t minus 2 is equal to 0. Okay. Now this is quadratic equation. Before that, see, is there any common factor among these three terms? See, 6 can be written as 2 into 3. Here we have 2 and here also we have 2. So take out 2 common and here we have 3t square and already 2 common, so minus t minus 1 is equal to 0. So transpose to 3t square minus t minus 1, 0 by 2, 0 by 2, 0. So, and this is quadratic equation because highest power of the variable is 2. This is quadratic equation in variable t. What is the general form of quadratic equation? Let us consider variable as t, dt square plus bt. This is standard form of quadratic equation. At square plus bt plus c is equal to 0. Here t is variable. So we have to solve this quadratic equation. Okay na? Ultimately we need value of t. For what values of t this velocity is equal to 0? That is our question. Okay na? So to find t values, we have several methods. We can use factorization technique or we have quadratic formula. So here I am going to use the quadratic formula because it is not easy to use factorization method for this equation. So anyhow, we know that quadratic formula. So we can solve this quadratic equation using quadratic formula. So what is quadratic formula? So t is equal to minus b plus or minus root over b square minus 4ac whole divided by 2a. So here ABC are coefficients. See, what is A? Here A means coefficient of t square. Here coefficient of t square is 3. And what is B? Here B is coefficient of t. Here coefficient of t is minus 1. And C means constant term. Here constant term is minus 1. Now plug in all the values in this formula, you will get t. T is equal to minus of b value minus 1 plus or minus root over b square minus 1 square minus 4ac. So a value is 3 and c value is minus 1 whole divided by 2 into a, 2 into 3. So t is equal to minus into minus plus, so 1 plus or minus root over 1 square value 1 minus into minus plus 4 3s are 12 whole divided by 2 3s are 6. So t is equal to 1 plus or minus root over 1 plus 12 13 by 6. So here we have two possible cases or two solutions, one time positive, one time negative. So t is equal to 1 plus either 1 plus root 13 by 6, or we have one more solution, one time negative 1 minus root 13 by 6. Here we have two solutions. T is equal to, if you solve this expression, you will get 1 plus root 13 by 6 value around, here I got 2.0816 seconds. So sorry, I got 0.7676 seconds, and or one more solution, minus 0 point value of this is minus 0.4342. Okay, no? See, we have two solutions, but this solution is not valid because time cannot be negative. Remember, as time cannot be negative, we cannot consider this solution. So our solution is t is equal to 0.7676 seconds. So first question answer is t is equal to, so first question answer t is equal to 0.7676 seconds. Therefore, velocity of the particle is 0 at t is equal to 0.7676 seconds. So finally we determined time at which the velocity of a particle is 0. So the time is t is equal to 0.7676 seconds. So second question, the position and distance travelled by the particle at that time. So at that time means 0.7676 seconds, at 0.7676 seconds. So we have to find the position and distance, position and distance travelled by the particle at that time. At that time means at t is equal to 0.7676 seconds. Okay. So at t is equal to 0.7676 seconds, what is the position of the particle? Okay, now, and what is the distance travelled by the particle? Okay. First let us find position. So first of all, what position of particle at t is equal to 0, initial position. So at t is, suppose time is equal to 0 seconds. Okay, now what is the position of the particle? What is the initial position of the particle? Here I am going to find initial position. T is equal to 0. At t is equal to 0. So here what is the equation for position? What is the expression for position? So x is equal to 2t cube, already given in the question. T square minus 2t plus 4. That's all. Yes. So put t is equal to 0. You will get initial position x naught. X naught is equal to 2 into 0 cube 0 0. 2 into 0 0. So you will get 4 meters. So what is the initial position of the particle? Initial position of the particle is 4 meters. Okay, now at t is equal to 0, position of the particle is 4 meters. Now we need position at we need position at t is equal to 0.7676 seconds. 0.7676 seconds. Let us consider it as let it be t1. This will be x1. So position at the time is equal to 2 into replace t by 0.7676 0.7676 whole cube minus 0.7676 whole square minus 2 into 0.7676 plus 4. Okay, so x1 is equal to, so if you calculate this value will be, first term value will be 0. Approximate values 0.9045 I got first term value, and second term value minus 0.5892 minus 2 into this will be 1.5352. Here I got 1.5352 plus 4. So if you calculate using scientific calculator, you will get x1 value, position value 2.7801 meters. This is position of the particle at t is equal to 0.7676 seconds. Next, we need distance travelled by the particle. So distance travelled by the particle at that time means distance travelled by the particle from t is equal to 0, t naught is equal to 0 to t1 is equal to 0.7676 seconds. Okay, na? 0 seconds to 0.7676 seconds. Okay, na? So distance traveled by the particle from t naught to t1, let it be s0 to 1, or we can take simply some s. Okay, na? Distance traveled by the particle at the time s is equal to formula modulus of final position t1, initial position, final position x1, initial position x0. Okay, na? Final position x1, initial position x0. Now substitute the values. S is equal to x1, how much? X1 we got 2.7801 minus x0 4, initial position 4 meters. You will get minus around minus 1.2199. Here negative sign tells us particle is moving in the direction particle is moving in the direction of negative x-axis. Okay, na? Particle is moving in the direction of negative x-axis. So modulus value is always positive. Remember, distance is scalar quantity, so it has no direction, so it must be positive. So 1.2199 meters. So this much distance travelled by the particle from t is equal to 0 seconds to t is equal to 0.7676 seconds. This is the second question answer. Next, third part, we have to find acceleration of the particle at t is equal to 0.7676 seconds. At the time means t is equal to 0.7676 seconds. So how do you get acceleration? Earlier we discussed about basic formulas of the differentiation, and also we discussed about velocity and instantaneous acceleration. Instantaneous acceleration is equal to rate of change of velocity with respect to time, dv by dt. So what is velocity? Velocity is equal to, so we have got velocity v is equal to 60 square minus 2t minus 2. Now we have to find derivative of this expression. A is equal to d by dt of, so here velocity is equal to what? 60 square minus 2t minus 2. Okay, so in place of velocity we can take this expression. Now apply differentiation. So d by dt of 60 square, distribute d by dt, minus d by dt of 2t, again minus d by dt of 2, d by dt of 2. So apply derivatives formulas. D by dt of 60 square. Here we have product of constant and variable function. So separate constant or take out constant out of the derivative. D by dt of t square is equal to 2t minus d by dt of product of constant and variable. Take out constant. Derivative of t 1. Derivative of constant 0. So acceleration is equal to how much? 12t minus 2. We have to find acceleration at 0.7676 seconds. So a 0.7676 is equal to, replace t by 0.7676 minus 2. So a 0.7676 is equal to 12 into 0.7676 minus 2. You will get, if you solve, you will get around 7.2112 acceleration unit meter per second square. This is third part answer. And last question, the distance travelled by the particle from t is equal to 3 seconds from t is equal to 3 seconds to t is equal to 5 seconds. The distance travelled by the particle. Okay, now let us say yes. So distance travelled by the particle from t is equal to 3 seconds to t is equal to 5 seconds. So let us consider 3 to 5. S 3 to 5. S 3 to 5. It means distance travelled. S for distance. Distance travelled by the particle from t is equal to 3 seconds to t is equal to 5 seconds. We need S 3 to 5. So how to find S3 to 5? What is the formula? Simple formula. Modulus of S5 minus S3. Final position minus initial position. Total distance covered by the particle from 3 seconds to 5 seconds is given by modulus of S5 minus S3. S5 here, S5 meaning, what is the meaning of S5? S5 means distance or position of the particle, not distance, position of the particle at t is equal to 3 seconds, let us say t3, next t5 is equal to 5 seconds, final position. We are talking about t5. S5 means final position. What is S3? Same, position of the particle, at t3 is equal to 3 seconds. T3 is equal to 3 seconds. Okay. So first let us find S5 and S3. Then by using this formula we can find the fourth question answer. Distance travelled by the particle from t is equal to 3 seconds to 5 seconds. Let us find S3. So position of the particle at t3 is equal to 3 seconds. Now what is S? So actually position we can take x here. It's okay, no problem. S is equals to, what is the expression for position? 3t cube, I think 2t cube. 2t cube minus t square minus 2t plus 4. Okay. So we need S3. Replace t by 3. So 3 cube minus 3 square minus 2 into 3 plus 4. So 3 cube 27. So 2 into 27 54. 3 square 9 minus 2 3s are 6 plus 4. 54 plus 4 58. 58 minus 15. 58 minus 15 how much? 43. So position of the particle at t is equal to 3 seconds is 43 meters. Next, let us find position at t5 is equal to 5 seconds. T5 equal to 5 seconds. S5 is equal to, replace t by 5. 2 into 5 cube minus 5 square minus 2 into 5 plus 4. 5 cube 25. 5 cube में 5 5 are 25. 25 5 are 125. 125 into 2 250. 5 square 25 minus 10 plus 4. 254 minus 35. 254 minus 35 how much? 219 meters. So position at 5 seconds is 290 meters. Now we need distance traveled by the particle from 3 seconds to 5 seconds. Modulus of S5 290, S3 43. 219 minus 43 how much? 219 minus 43. So 219 minus 43 is equal to 176 meters. So distance traveled by the particle from 3 seconds to 5 seconds is 176 meters.